Okay, welcome everyone. For this video, what I'm going to do is go over some basic calculus functionality that you can do in SpaceTime. So let's start by defining a function f of x. Let's start with a polynomial, say x to the fourth plus x cubed plus 4x squared minus 7x plus 5. Okay, so we've defined a function f of x just like you would normally write it on a board or on a piece of paper. And if we want to take the derivative, what's really cool is that the official function is the d function. So if you want to do f of x with respect to x, boom, there it goes. It differentiated it with respect to x. But what's also really nice is that we use prime notation as well. So all I got to do is type f prime of x, and I get the same thing. Another thing you can do is just, again, I can leave open parentheses as much as I want. And boom, see, it auto-detects the variable as well. So probably the prime notation is what you're going to want to use for simplicity. And what's really nice is I can take a second derivative by doing primes, or that many derivatives. That would be 4 derivatives just by adding on primes. So that's derivatives. Another thing we can do is integrate f of x, and we get the antiderivative if we don't specify any bounds. We can, of course, specify bounds, so we could do a comma b and have it evaluate it in in an expression, not numerically. Of course, now all we got to do is put in, say, 1 to 5, and we get an answer. Again, the first answer will come out fraction form, depending on your settings, and if you enter it again, it gives you a decimal value. So that is what it's like for polynomials. You can differentiate, integrate a lot of other functions, but polynomials are really nice and simple. If I do what I did was an apple enter to get it to plot automatically, and so we get an image like this. We can look at the minima, look at the zeros if it has any, and local max, but this guy doesn't have any local max. So what you've got here is just a plot, and we can zoom in and out by double clicking. So those are also limits too. You can do limit of f of x as x approaches, say 3. Polynomials are continuous, so it's the same as f just evaluated at 3. But you can do things like x minus, or say x squared minus 9 divided by x plus 3. And if you take the limit as x goes to -3, boom, you get -6. So the key thing here is with this limit is you can't just plug in -3, because then you get a 0 over 0. And so what the limit function is doing is it's factoring for you, canceling stuff out, and then computing it. So it's basically doing the algebra for you. So that's that. Another cool thing that I like to do to kind of show off space-time is let me change f to be sine of x. So I get that, and if I just want to do a quick plot of sine of x, I get it right here. It's the friendly sine function. And now, if you take a calculus class, you eventually learn about the tangent line at a point A. And so the tangent line is given by, for a point A, it's f of A plus f prime at A times x minus A. And I mean, this is exactly the way the formula would be written, say on a blackboard or something in class. And if we do this, what we get is that this prime notation that we showed earlier actually works for f prime then evaluated at A. So it took the derivative first and then evaluated it at A. That's how we ended up with the cosine of A here. And so if we define this to be another function, let's not define it to be a function yet, but we can plot both of these together if we specify the value of A. And the way we plot them together is we make a list. And so a lot of the things that work for just single expressions, if you put it in list form, it works. And here what we'll see is that when we define a to be, oh, let's do the derivative at pi over 2. So Apple Shift P gets you the pi symbol, or Control Shift P on a PC, pi over 2. So that should be that little peak. And then if we hit enter, it'll evaluate it. And then if we do Apple enter, then we get the tangent line. And so if you saw before, it output a list, which was sine of x, comma 1, and that is exactly what the tangent line turns out to be. It turns out to be the line y equals 1. So what's also kind of cool too is, I'll take this Apple C, and so I did an Apple C to do a control, to do a copy of that line. Now if I do a shift enter, that's how I got the extra lines. And so I want to plot this again, but now what I want to do is use the scroll function A, and I'm going to let it go for values between, let's say -5 to 5 in increments of 0.01. And let's see if this works. I think I need to clear it out first. Yeah, so this will probably happen to you a lot, is you'll define a variable A here, and then you'll want to use it again as a local variable. And so one of the things that you can do is you can either you can use a clear statement. So what I'm doing now is I'm going into let's see, edit, and I'm doing a insert entry. So that would be the same as a Apple shift, Apple plus. So Apple shift equal sign gives you another line. And so if I do a clear on A, and I put it in quotes, it'll return a 0. That lets you know that it did something. And then now if we do it, the value of A is cleared, and if you'll notice, there's a scroll bar that's appeared here. And oh, see, the window's doing something funky, but you've got what looks like to be the tangent line. And so what you're going to do then is if you go into options and you scroll down to auto window, uncheck that. When you uncheck that, then you go back here, and then you get exactly what you would expect. So it's this nice, smooth tangent line to the function. And again, I set the scroll bounds -5 to 5 to correspond to the x-min and x-max. You don't have to do that, so I could change this to a -10 if I wanted to. And it starts way back there, and I bring it forward like so. Okay, so that's one thing to do. Now, the last thing I want to do is sort of a variation on this, which is I want to introduce the time variable. So this is, I've never really used this in a calculus class or anything, but this is just kind of cool. So if I do f of x plus t, what I get is sine of x plus t. Okay, so this is a function now of x and t, or just think of it as sine of x, and we're giving it an argument that is essentially a time parameter. So it evaluates to this expression, and now if you do an Apple enter to plot it, what you get is a sine wave that is now incrementing the value of t in time. So t is sort of mnemonic for time, and as you can see, when t is equal to, say, 49.8, this is sine of x plus 49.8. And you keep going it. You can keep it going like that. Well, that's kind of neat. So then one of the things that you can do is, this is what I like to usually show people when I show them SpaceTime, is let's now look at the tangent line at 0. So this is going to be f of, so x is going to be 0, so it's going to be f of t plus f prime at t times x minus 0, so just x by itself. And then this should work. Boom. And there we go. So what it's doing is it's plotting sine of x plus t. So it's letting the, I guess that would be, I forget what they're called, but I guess it's the shift, go forward in time. And then this is just plotting all the tangent lines when x is 0. And this is I just think this is a neat little graphic to show people when I show them SpaceTime. The other thing to keep in mind is, okay, you can go full screen. You've got the controls right there. That's still there. So let's pause that, go back, double click. Same thing over here with the scroll. When you double click, you get the scroll bar at the bottom. There it is. Okay, so that's sort of some of the basics for calculus functionality. There's a lot more, but this is some of the basics.